Welcome to a new class of intermediate microeconomics. And today we're going to deal with two chapters, chapters 5 and 6 of the book. And we are going to talk about income and price effects. But before we go into a lot of technical detail, let's start with an appetizer. So our empirical application of today is a study by Giamandrioni and Miller out of 2002. And as you will notice when reading the course book, throughout the book we assume that people don't have a lot of regard for other people and that they only care about their own well-being. And this is typically also the criticism that a lot of people have about the so-called Homo economicus, that we model human beings as being entirely selfish, and that our modeling framework does not allow for richer preferences. So it doesn't allow to include social preferences. But is that criticism warranted? And the answer to that question is no, because our utility framework is very well able to incorporate richer sets of preferences that also allow people to engage in altruistic behavior. And that is good news because we observe a lot of altruism around us all of the time, because people give blood, people donate to all kinds of charities, and they also volunteer, so they also give their time. And in general, people do not only care for their own well-being, but they also tend to care to some extent for the well-being of others. And the question then is, can we rationalize this altruistic behavior? So we observe in practice that people behave altruistically. Can we rationalize that behavior within our utility maximizing framework? So is there a utility function that rationalizes altruistic behavior? And that's a question that Giamandrioni spent his life studying, because he's one of the most well-known, if not the most well-known economist studying altruism, social preferences, and charitable giving. And in this study, they address this question by applying the axioms of revealed preference to the altruistic choices of subjects in a laboratory setting. So they use the methodology of experimental economics. That methodology has become much more prominent in the last 20, 30 years of economic research. And as we will see at the end of this lecture, they applied it very fruitfully to investigate whether people make consistent altruistic choices. But before we get to that, we need to get first to a lot of theoretical detail that's in chapters 5 and chapter 6, but also summarized in this lecture. So from the previous lectures, we already know that people maximize their utility, and that culminates into a demand function. And if it's a Marshallian demand function, it's a function of the prices of the goods and of someone's income I. And what economists are particularly interested in is what happens if to demand, if there's an exogenous shock to the prices or an exogenous shock to the income. And the shock may be positive or be negative. How does that change the quantity demanded of a certain good? Well, chapters 5 and 6 deal with exactly this question. So chapter 5 studies the question, what happens to the demand for a good, say good X, if the price of that good, Px, changes, or when the household's income changes. And chapter 6 deals with the question, what happens to the demand for a good, say good X, if the price of another good, say good Y, changes. That, in a nutshell, is the content of chapter 5 and chapter 6. So let's start with changes in income. So if someone experiences an a change in income, then he experiences a change in purchasing power. So if income increases, the purchasing power of that individual increases, which actually means that given his new income, he has more consumption bundles that he can afford than he could before. So the individual's budget set has widened, and the opposite happens if a person's income decreases. If someone's income changes, nothing happens to the prices that he faces on the market. So the relative prices of good X and good Y in a two-good economy do not change. It also means that, okay, the budget set widens, but the slope of the budget line is identical as before, because the slope only depends on the price ratio of the different goods. And as a result, also the marginal rate of substitution at the optimal point is not affected. The individual maximizes utility at the optimum. If he's not in a corner solution, the marginal rate of substitution is identical to the price ratio. The price ratio didn't change because of the change in income, so nor will the marginal rate of substitution. The question then is, how does the demand for a good change if income changes? Well, that depends on an individual's utility function, and we will consider a number of cases. So the first case is where in a two-good economy, all goods are normal goods. So we have two goods, and if both goods are normal, it means that if income increases, the individual will increase his or her consumption of both goods. So in picture, suppose that we start with an income that's related to the budget line, which is the line over here. Then the individual maximizes his utility by consuming the consumption bundle depicted at point A. At that point, the slope of the indifference curve is tangent to the budget line, so the marginal rate of substitution is identical to the price ratio, and the utility level that the individual is able to obtain is U1. When income increases, then the budget set widens. The slope of the budget line doesn't change because prices are unaffected. So we get a parallel shift of the budget line outward from the origin, and the individual's new optimal consumption bundle is at point B. And at point B, his utility level is higher than before because he can now reach the higher indifference curve U2. And as you can see, in this situation, both goods are normal because if we compare point A and B, at point B, he consumes more units of X and more units of Y. Now then, if we further increase this individual's income, then he can reach an even higher indifference curve by consuming consumption bundle C. And also here, compared to point B, he has increased the consumption of both good X and good Y. So both goods remain normal goods. The situation is different if one of the goods is a so-called inferior good. So that's a good of which the consumption decreases as income increases. And in this picture over here, what we observe is again increases in income. So we have parallel shifts in the budget line. Good Y is a normal good because if income increases, the consumption of good Y increases, but good X starts out as a normal good. So for the first increase in income, the consumption of good X slightly increases, but then if we further increase income and the optimal bundle moves from point B to point C, we see that the consumption of good X is backward bending, so the consumption of good X goes down. And in this range, good X is an inferior good. So in an economy, at least one of the goods needs to be a normal good. So in a two-good economy, like the one that we considered here, at least one of the goods needs to be a normal good. Question is, why? Now, the answer to this question is, suppose that you have an increase in income. So your income increases by delta y. Then you don't save, so you need to spend this additional income on something. And if both goods are inferior, it means by definition that your increase in income would lead to a reduction in the consumption of both goods. And that would mean that you would not spend your entire income. And of course, money itself doesn't buy a utility, so you should buy some units. So at least one of the goods needs to be a normal good. That's the intuition. Of course, we can also do it mathematically. Suppose that we have a positive change in income, and now we just use the budget line. So we use the budget line because at the optimum, the old optimum and the new optimum, we want to consume a consumption bundle that's actually at the budget line. We don't save money. So when we rewrite the budget line, then and we solve for good y, so then we have that the total change in income needs to be spent on additional units of good y, or the money needs to be spent on additional good units of good x. So suppose that we have that good x is an inferior good, so we have a positive change in income, but we reduce our consumption of good x. That means that this part over here is positive, so this is negative, and with the minus sign it becomes positive. We assume that we have a positive change in our income, so this part is positive as well, so the entire right hand side is positive. Then it also needs to be that the left hand side of this equation is positive. Well, prices cannot be negative, so the only possible solution is that delta y is positive as well. Stated differently, we have a positive change in income. If we reduce our consumption of good x, then next to the extra income, we also have some additional income to spend because we consume less of good x. Well, then we definitely need to spend it on additional units of good y. Otherwise, the budget line, the budget set, the budget constraint will not be satisfied. Okay, so the total price, the total change in demand for a good due to a price change is more complex than if we only consider changes in income. So if we change the price of a good, then we get a change in the budget constraint, but we also get a change in the slope of the budget constraint. So if we move to a new optimal consumption bundle, we not only move to a different indifference curve, but we also in the new optimum have a different marginal rate of substitution than before. So we no longer have a parallel shift of the budget line. And this total impact of a price change is composed of two different effects. The first one is called the substitution effect. And it means that we need to equate the marginal rate of substitution to the new price ratio. And in practice, it means that we remain on the same indifference curve, but we adjust the marginal rate of substitution, and the consumer will substitute away from the good that has become relatively more expensive. And it will substitute towards the good that has become relatively cheaper. And the second impact is the income effect. So if the price of one of the two goods changes, this will always impact the real income of an individual, so what he or she can do with his income, and therefore the purchasing power of the individual. So graphically, we get the following, and this is something that's familiar to you from your introductory microeconomics course. Suppose that we have a price decrease in the price of good X, then it means that if this is our original budget line and our original optimal consumption bundle is point A, that allowed us to reach an indifference curve and utility level U1. Now the price of good X decreases, meaning that if we would spend our entire income on good X, we now can buy more units. So the budget line pivots around this point over here outward. So this is our new budget line. If we would spend our entire income on good Y, we can buy exactly the same number of units as before. If we spend it on good X, we can buy more units than before. And now we are able to reach a higher indifference curve U2 by consuming instead bundle B. So the total increase in the consumption of good X is equal to this horizontal part over here. And now we decompose it into the substitution effect and the income effect. And we first do it graphically and then we do it mathematically. So to isolate the substitution effect, we examine what would happen if we stay put at the original utility level, but we adjust the price ratio to the new price ratio. So we fix the utility level at the old level, so we stay at the old indifference curve U1, but we adjust the slope of the budget line such that it's consistent with the new price ratio after the price change of good X. So if we do that, then we reach the point here, point C. So we are still on the same indifference curve, but now the slope of the budget line is identical to the new price ratio, and we select a point that is tangent to the indifference curve, which happens to be point C. And then the change from bundle A to C is the substitution effect. So we can see that good X has become relatively cheaper. So we have substituted away from the good that has become relatively more expensive. So if you compare point A and C, you will see that you compare less units of good Y in consumption bundle C. And we substituted towards the good that has become relatively cheaper, good X. So in the new consumption bundle, we have more units of X than in the old one. This is the substitution effect. Then the income effect. The income effect is the effect that's due to an increase in purchasing power. So there's more that we can do with our money than before. So even if we would buy the old consumption bundle A, because now good X has become cheaper, compared to the previous case, we would now have money left on the table. We would have extra income that we could spend on additional units of either good X or good Y. And this income effect is the change in consumption bundle from point C to point B. So because we have income left after we have bought the old consumption bundle, we can now reach a higher indifference curve. And this higher indifference curve is associated with the utility level U2 and allows us to consume consumption bundle B. So first we have a change from A to C, then we have a parallel shift of the budget constraint, and the change in consumption bundle that results from that parallel shift is the income effect. So for normal goods, the substitution effect and the income effect, they operate in the same direction. Meaning that if a good is a normal good, if it becomes relatively cheaper, then you buy more of it. Because it has become relatively cheaper, you can do more with your income, and this additional purchasing power is also partly spent on increasing your consumption of good X. So it works in the same direction. And then if you change the price of a good, the impact on the demand of a good is unambiguous. It's clear-cut. If the good is a normal good, if the price decreases, then the demand for that good will increase, and if the price increases, demand will decrease. For inferior goods, it's less clear-cut, because there the substitution effect and the income effect, they work in opposite directions. So the substitution effect makes you consume more of the good that has become relatively cheaper. But if it's an inferior good, well, the additional income means that you will reduce your consumption of the good that has become relatively cheaper. So if that's an inferior good. So for inferior goods, the total effect, so the substitution and income effect of a price change, is undetermined. Usually the substitution effect will dominate the income effect, because most of the goods that you consume, you only spend a small share of your income on the consumption of that good. So for example, if shampoo becomes more expensive, then you will substitute away from shampoo to some good substitute. It also will reduce your purchasing power. There's less that you can do with your income. But if shampoo is an inferior good, that means that you will buy more shampoo because your income has decreased. However, the income share, expenditure share of shampoo is small, so the income effect will also be very small, meaning that the substitution effect, the effect of the shampoo itself having become more expensive, will dominate, and your uncompensated demand of shampoo will decrease. However, there's an exception, and these are the so-called given goods. And given goods are goods where the demand of a good increases as its price increases. So, and that's a paradox, because it's something that is counterintuitive. Normally you would expect that if the price of a good increases, you will reduce your consumption of that good. For a given good, you increase your consumption of that good, because the reduction in purchasing power leads you to increase your consumption of the inferior good to such a great extent that it will dominate the substitution effect. Later in this lecture, I will get into more detail on given goods. And now we will see how changes in income and prices translate to changes in demand. So on the left-hand side, we have the indifference curve and the individual's budget set. And on the right-hand side, we have the demand curve. So the demand for good X as a function of the price of good X. And in order to derive the demand curve, we hold the price of all other goods and the individual's income fixed. So we have these bars above the price of the other goods and above the income level. So what happens if the price of good X increases? So we start out with price Px that allows us to consume consumption bundle B associated with indifference curve U2. Now the price of good X increases to Px2. So this is not a square, but this is just an index that it's the new price. At this new price, the budget set or the budget line pivots inward, and the new optimal consumption bundle is at point D, and the number of units of good X that we consume reduces from x1 to x2. That gives us a second point in our demand curve, because we now know that at prices px2, the demand for good x is equal to x2. Then we can further increase the price of good x, and that allows us to get the entire demand curve for good x. And, well, as already discussed, usually when the price of a good increases, the demand for that good will decrease. And that's what we observe here. We have a negative relation between the price of good x and the demand for it. So one more iteration of things that you already know. If we have a change in the price of the good that we consider, then we have a movement along the demand curve. So we shift, or we move to another point on the same demand curve, but the demand curve itself stays at the same position. If someone's income changes, or we have a shock to the price of another good, then we have a shift to the entire demand curve, and the entire demand curve will either shift inward or outward. So we talk of an increase in demand when we mean that we have an outward shift in the demand curve, and we say that we have an increase in the quantity demanded if we refer to a movement along a given demand curve that itself stays at the same position.